All right, Algebra 1, welcome to our first factoring notes. So go ahead, label these notes. Chapter 7, we are factoring out a greatest common factor, or how we say, factoring out a GCF. Okay, so these are some of these special kinds of notes where you actually only need to write down a few things. So the symbol of things that I need you to write down is this, our little pencil buddy here. All right, so if you see a little pencil buddy on your screen, I'm going to ask you to write it down. If not, you're more than welcome just to watch and then copy down what you need to. So first things, we're just going to talk a little bit about factors, and hopefully you're just answering this in your head. Is 5 a factor of 12? No, it's not a factor of 12. Is 2 a factor of 12? Yes, it is, because 12 divided by 2 is 6. It works out nicely. And then 1 is also a factor of 12. 12 divided by 1 is 12. So all of those kind of worked out a reminder of what a factor is. So then when we say we found a factor, what we mean is that we found a number that multiplies with another to give you the result. For example, you can divide the number by the factor and it goes in evenly. Pencil buddy, get those pencils out. Factors, numbers that multiply together to give you another number. So let's go ahead. I'll actually keep your blue screen up here so we can have a little idea together. List the factor pairs of 12. So factor pairs of 12, we can go ahead and say, well, I like to start with 1. So 1 times 12 is a factor pair. We can also say another factor pair would be 2 times 6. We can keep going here. I like to just kind of count up. So 3 times 4. And then if you notice here, if I start counting up more, I just start repeating my factor pairs. And we can actually do a prime factorization. And that means that we're going to go ahead and split 12 into the prime numbers. So I like to say is 2 times 2 times 3. That's called a prime factorization, meaning you kind of break it all the way down to those prime numbers. So those are all of our factors of 12 there. And we know we correct because we can go back and multiply them and they all equal 12. So a reminder on your distributive property, you take the number on the outside, multiply it to the numbers on the inside, 5x plus 5. It's simple. Hopefully you're with me on that distributive property. So what does that have to do with factors? Well, I will tell you. All right, if you're asked to factor it, it means that you're supposed to find the two things that multiply to give you 5x plus 5. So I'm going to scroll up again. What are the two things that would multiply together to get you 5x plus 5? Well, here it is, right? So basically what the factoring is doing this distributive property backwards. And I would take the 5 out. So we go ahead and we write our GCF. I'm going to get to that in just a second on the outside. And then you write the factor on the inside. So the two factors here of this are 5, and then your second factor is x plus 1. All right, so pencil buddy here. Distributing is multiplying a term in. So we multiply this 5 into the parentheses, giving you 5x plus 5. And factoring would then be doing the opposite of that. Factoring is dividing a term out. So we now take this 5, put it on the outside of the parentheses, and write what's left over when we divide it out of each term on the inside. Okay, keep those pencils out because you are writing the definition of our GCF. So GCF stands for greatest common factor. Once again, GCF stands for greatest common factor. And the greatest common factor is the largest item of all terms have in common. So GCF can be a number, a variable, or a combination. For our example here, the GCF of 5x plus 5 is 5. meaning that the term that's greatest between both of these terms is 5. It's the term that must have been distributed in originally. So our greatest common factor is that you're going to remember it is the goal to figure out the greatest amount that can be divided out. So for example here, 6x plus 24 have a common factor of 3, but the greatest common factor is 6, right? Our GCF here is 6. So we would go ahead, we would say 6, we write our GCF here, and then we put the rest of it in the parentheses, so x plus 4. That's how we would factor that. All right, so pencils down for just a second. We're going to try a few together with our Coyote and Roadrunner here. So first thing is to figure out your GCF. Now, I like to do it numbers and then variables. I'm first looking at my numbers here, 12 and 16. They both have a GCF of 4. Ooh, 4. So the first thing is that you go ahead, you write your GCF here on the outside, and then you figure out, okay, 4 times what? That is going to go ahead and give us a 3x, 4 times 4. And we're going to go ahead just to kind of double check. 4 times 3x gives you 12x. 4 times 4 is 16. So that works out for us. All right, let's try this one here. GCF, check the numbers first. 7 and 16 don't have anything in common, giving me my variable. So x squared and x have a common x. So our GCF for this is simply x. Again, you write your GCF here on the outside. And then you have to say, okay, x times what would get me 7x squared? That's going to be 7x. X times what gets me 16x? That's going to be 16. And then you kind of do that mental check to make sure that it works out. It does. All right. On this one, when you have a whole bunch of variables and numbers, I'd like to check my numbers first. So I'm looking at 6 and negative 30. That has a greatest common factor of 6. Greatest common factor of 6. Now I'm going to check my x's. X cubed and x squared. This one's a little tricky because the greatest common factor is actually going to be x squared. They both at least have an x squared in common. So when we're factoring this, start with your GCF on the outside of your parentheses, 6x squared. Now we're going to take everything and write the rest of it inside our parentheses. So 6x squared times x is going to give us 6x cubed. And 6x squared times negative 5 is going to get you negative 30x squared. So double checking that we're correct, do that kind of mental math. How do you know you're correct? You go back and you multiply your term. So check by distributing. All right, one question here is that you're going to list all the factors of 11. And 11 only has one factor pair. It's 11 times 1. And what do we call this? We call that prime, right? When a number is only divisible by itself and 1. So for example here, when I'm looking at 2x plus 7 and I want to factor out a GCF, 2 and 7 have a common factor of 1, and x and 0 have a common factor of 1. So my GCF here is 1. And when my GCF is 1, I'm not going to factor out a 1. It simply just means that this is prime. So there's no GCF greater than 1 here. We answer that as prime. Second to last one here is that your 14x plus 7. So these definitely both have a GCF of 7 here, but double check it, which one's correct here. If I multiplied this guy out, it would get me 14x. That's not my answer that I had. This guy, Roadrunner's correct, usually as always with our Roadrunner and Coyote. This guy, when you multiply it out, gets you 14x plus 7. So double check that 1. So moral here, even if you factor out everything, there must still be a 1. Remember, you should always be able to distribute. and get back to where you started from. Last one where you're watching is that when you have a negative on the outside, it's so important to actually pull this negative out to our front GCF term. So this should actually be negative 4 times 2x plus 3. This is our correct answer here with the negative as part of our GCF. This is just what we said here. Best answer like we did before, negative 4 times 2x plus 3. Okay, so pencil buddies, grab those pencils again. You've done a lot of watching. So step 1 is determining the GCF and write it in front of the parentheses. Watch out for those negatives, never leading negative in the parentheses. You're then going to divide out the GCF from each term and write it. What is left over in the parentheses? Check your answer by mentally distributing, and if it's not factorable, write prime. So you might have to pause that to write everything down, but you guys are all writing some examples here. All right, so first things first, looking for our GCF, I like to check with the numbers. So 6 and 24, that has a GCF of 8. Now x and y don't have anything in common, so I'm just going to leave them as they are. So 8 times 2x is going to get me 16x minus 3y. Do the mental check. 8 times 2x is 16x. 8 times negative 3y is negative 24y. Good to go. Okay, example 2 here. Check for the numbers first. 8 and 1 don't have anything besides 1 that we can factor out. So now I'm going to go ahead and factor out an m. All right, what am I left over with? I know this guy is 8m, because m times 8m is 8m squared. But don't forget that 1, when you factor out m divided by m is 1. Always do your mental check. 8m squared minus m. Yep, that works for us. Okay, here's that tricky one with the negative at the front. Again, always start with the numbers, negative 10 and 50. That's a negative 10 in common for those. X cubed and x squared, that's an x squared in common. So negative 10x squared is my GCF. Now we write what's left over. I have to multiply the first term by x. So 10x squared times x is going to get me 10x cubed. And this one actually should be a negative 5. And now we do that mental check just to make sure that works. Negative 10x squared times negative 5 is a positive 50x squared. Both work. Okay, starting with my numbers. 6 and 5 don't have anything in common. And a cubed and b cubed, they're two different variables. They don't have anything in common. If I don't have anything in common besides 1, this is prime. So we answer it by saying prime. We don't leave a blank. We actually answer that one. All right, sometimes they get a little bit longer here, but we can still factor everything out. So we factor everything out by starting with our numbers. And starting with 3, negative 9, and 6. So 3 is the greatest common factor between those numbers. Then let's move on to our variables. X to the 4th, x cubed, y, and x squared, y squared. I said x in every single term, so I know that there's going to be an x that's in common. And then we have to go ahead and say what that exponent is. So that's going to be x squared. Now I have to go ahead and inside those parentheses, making sure that we are writing everything out. So 3x to the 4th times what is going to get you 3x squared. X squared. Minus, this is a 3xy. And last one, plus 2. Now I already have the x squared, so I don't have to write that one, so it would be times 1, but I do have to write the y squared. And this is really important when you get these long ones that you do these mental checks. So 3x squared times x squared, that's 3x to the 4th, that works. 3x squared times negative 3y xy gets you negative 9x cubed y. And 3x squared times 2y squared gets you 6x squared y squared. So lots of mental checking on that one, but it's really important that you do it. All right, very last one for you. Again, we kind of have this negative on the outside, so it's really important that we go ahead and that negative is part of your GCF. Start with your numbers, negative 16 and a positive 24. We're going to pull out a negative 8, and then we're looking at our x's. I got an x squared and a y. That's my GCF. That's as much as I can pull out from every single term. Now write the rest inside your parentheses. I'm going to have to multiply the negative 8 by 2 to get to the negative 16, x squared to get to the x to the 4th, and then times y, I don't have to write the plus 1. All right, now our second one. I'm going to have to multiply it by a negative to get to a positive 24. So a negative 3. The x squared's already in there, but I do have to multiply it by a y squared to get to y to the 3rd. And we know we're correct by doing those mental checks. We kind of did it as we went along with distributing it back out. And that's our first step of factoring. Very nice job, Algebra 1. We'll see you soon.